Welcome to MRL. In this learning session, we'll be learning the solutions of exercise set 4.4 of Ganita Manjari. Chapter is Identities, that is Exploring Identities, 9th Standard NCERT textbook. Now the first question here is we have to fill in the blanks. We are given here a polynomial of second degree. We have to find the factors and they can be found out by simple middle term splitting method. So now here we have to get minus 11 in the center. That when I split it, it becomes minus 8 and minus 3, and when I multiply minus into minus is plus, 8 is 24. So therefore the factors are s minus 8 and s minus 3. We can go via middle term splitting method. Now the second example is 3x minus 7. This is not given to us. X plus 1 is given and 3x square minus 4x minus 7 is given. So we have to find out one factor. Now a very simple method is go for middle term splitting method again. When I add, I should get minus 4. When I multiply, I should get minus 21, and therefore the factors are minus 7 and plus 3, and therefore the fact 1 is x plus 1 is already given to us. So the second factor is 3x minus 7. Otherwise, you can directly go for middle term splitting method and find out the second factor. Now the third example is 10x square minus 11x minus 6. Again here I have simplified here 10x square minus 11x minus 6 by middle term splitting method. I have got 2x minus 3 and 5x plus 2 are the factors. So therefore the factors are 2x minus 3 and 5x plus 2. Now the next example is 6x square plus 7x plus 2. Now we have to find the factors here again by middle term splitting method. I have found out the factors are 2x plus 1 and 3x plus 2. So that is how we can find out the factors and fill in the blanks there. Now the next question is to find the value, now 41 square. Now 41 can be written as 40 plus 1 whole to square. Therefore I can go for a plus b whole to square identity, that is a square plus 2b plus b square, and here a is 40 and b is 1. Substituting we get 40 square, that is a square, plus 2ab is 2 into 40 into 1, b square is plus 1 square. 40 square is 1600 and this is 80 plus 1, therefore the answer is 1681. Now coming to the next example, we have to find 27 square, and 27 can be written as 30 minus 3, and I can go for a minus b whole to square identity. Therefore we have a square minus 2b plus b square. A is 30 here, b is 3, and therefore it is 30 square minus 2ab, 2 into 30 into 3 plus 3 square. 30 square is 900, and this becomes 3 is 9 into the 18, 180 and 9, and therefore it will be 909 minus 180, and that is 729 is the answer. Now the next example is 23 into 17. Now there it's a product of two numbers, so I have to go for the nearest number is 20. So 20 plus 3 and 20 minus 3, it is a plus b into a minus b form. Therefore it is a square minus b square. A is 20, b is 3. Therefore 20 square minus 3 square, that is 400 minus 9. The answer is 391. The next example is 135 square. Now here I can go for a plus b plus c form. Therefore it is 100 plus 30 plus 5 whole to square, and we know that a plus b plus c whole to square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca, and therefore I have a as 100, b as 30 and c as 5 here. Substituting we get 100 square, that is a square is 100 square, b square is 30 square, c square is 5 square. 2ab is 2 into 100 into 30, 2bc is 2 into 30 into 5, and 2ca is 2 into 5 into 100. Simplifying we get 1 followed by 4 zeros, 3 square is 9, 900, 5 square is 25, and here it is 6 followed by 3 zeros, and 5 is 15, 300, and here 10, that is 1000. When we add, we get 18,225. Now coming to the next example, that is 97 square. 97 square can be written as 100 minus 3 whole to square, and it is a minus b whole to square. Therefore a square minus 2ab plus b square. We can write a as that is a is 100 here, so 100 square minus 2ab, 2 into 100 into 3, and b is 3, therefore it is plus 3 square. So 100 square is 1 followed by 4 zeros. Here it will be 600 minus 600 plus 9, so it will be 10,009 minus 600, therefore 9,409 is the answer. Now coming to the next example, 18 into 29. 18 into 29 can be written as 20 minus 2 and 20 plus 9. Therefore we have got here the first term is the same, the second terms are different. Therefore I can go for an identity, that is x plus a into x plus b, that is x square plus a plus b into x plus ab. So x here is 20, and a is minus 2, and b is plus 9. So substituting we get 20 square plus minus 2 plus 9 into 20 plus minus 2 into 9, and therefore 20 square is 400, minus 2 plus 9 is 7 into 20 minus 18. So 400 plus 140 minus 18. So 400 plus 140 is 640, 640 minus 18 is 622, and that is the product of 18 into 29. So the next example is 34 into 43. 34 is 40 minus 6 and 43 is 40 plus 3. Again we can go for the same identity. So here x is 40, a is minus 6 and b is plus 3. So substituting we get a square is 40 square, a plus b is minus 6 plus 3 into 40 plus minus 6 into 3, and therefore it is 4 square is 1600, minus 6 plus 3 is 3, 4 is 12, 120, and plus into minus is minus 120, and minus into plus is minus 18. So adding we get 1600 minus 138, therefore the answer is 1462. The next example is 205 whole to 2, that is 205 square, and this can be written as 200 plus 5 whole to square. So again a plus b whole to square form. So it is a square plus 2ab plus b square. A square, a is 200 here, b is 5. So it is a square is 4 followed by 4, 2 square is 4 followed by 4 zeros. 2 into 2 is 4, 4 5 is 22,000, 5 square is 25. Adding we get 42,025 is the answer. Now coming to the next example, that is third example, that is factorize. Again here we have got 9a square plus b square plus 4c square minus 6ab plus 12ac minus 4bc. Now if you look at this, we have three square terms here, 9a square, b square and 4c square. Therefore very clearly it is a square, it is a plus b plus c whole to square form. So but we have to identify whether these three terms are the same. Now let us see. 9a square can be written as 3a square, and b square can be written as minus b whole to square. I will tell you exactly why I have taken minus b here, and 4c square is 2c whole to square. Now the next term is 2ab, 2 into 3a, 2 into 3a and minus b, plus into minus is minus, and that is minus sign there. 3 into 6, 3 into 2 is 6, 6ab, therefore I have taken minus sign here. Now 12ac, that means I have to multiply to AC, 12ac, I have to multiply it. A is 3a, and c is 2c, so it will be 2 into 2c into 3a, so it will be plus into plus is plus 2 to the 4 there is 12, 12ac is correct. Then next is minus 4bc. Now if you look here, I have taken minus bc, b is minus b and c is 2c, therefore plus 2 into minus b into 2c, plus into minus is minus, and 2 to the 4, 4bc, and that is exactly the reason why I have taken minus b. If you look at the example, there are two minus signs, the first term and the second term, therefore I have taken the minus b here, so that I get minus 6ab and minus 4bc there. So try to remember that. So therefore the answer is 3a minus b plus 2c whole raised to square, and the factors are 3a minus b plus 2c and 3a minus b plus 2c. So that is how we use the identity to find the factors. The next example is 16s square plus 25t square minus 40st. Now rearranging 16s square minus 40st plus 25t square, this is a square term, this is also a square term, and once it is a square term I can use an identity, and that is a square minus 2ab plus b square, but and get the answer as a minus b whole to square in the factors. Now the 16s becomes 4s square, 25 becomes 25t square becomes 5t square. Let us check the middle term now. It is minus 2ab, so minus 2, 4 into 4s into 5t, multiply 4 5 the 22 to the 40, 100% correct. Therefore it is of the form a square minus 2ab plus b square. So the answer is a minus b whole to square. A is 4s, so 4s minus 5t whole to square. The factors are 4s minus 5t and 4s minus 5t. That is the answer for that. Now coming to the next example, r square minus r minus 42. Now I can go for middle term splitting method. When I add I should get minus 1, and when I multiply I should get minus 42, and the split can be minus 7r and plus 6r, because minus 7 plus 6 is minus 1, minus into plus is minus 7 6 is 42. Therefore I have converted the trinomial into 4 terms here, that is r square minus 7r plus 6r minus 42. Group it, that is I group it and take r outside. If I take r outside I get r minus 7 here, and 6 outside I get r minus 7 again r minus 7 is common, take r minus 7 outside, what remains is r plus 6, and that is they are the two factors. So therefore understand here, first we have gone for middle term splitting, second we have taken HCF common, again third again I have taken HCF common, and I have got the two factors here. Now the next example is 49g square plus 14gh plus h square. Now 49g square is a square term, h square is also a square term, therefore it can be written as 7g whole to square, this can be written as h square. But the middle term, let us see, plus 2, a is 7g and b is h, 7 to the 14, 100% correct. So therefore it is a square plus 2ab plus b square form. So I can go for a as 7g and h as and h is the b term here. So a plus b whole to square. So it will be 7g plus h whole to square. So 7g plus h into 7g plus h are the factors of the given trinomial. Now here we are given 64u square plus 121v square plus 4w square and minus 176uv minus 32uw plus 44vw. Now if you look at this example, here we have a square term, here we have again a square term, and here also we have a square term. That means 3 square terms are there. Therefore 100% the identity, possibly the identity would be a plus b plus c whole to square form. So therefore let us see. Now 64u square is 8u whole to square. I have taken minus sign. Again I will tell you why I have taken minus here. Plus 121v square becomes 11v whole to square, and 4w becomes 2w whole to square. Now the first 3 terms are clear, but now let us check the other 3 terms. Now here I have taken plus 2ab, 2 into minus 8u and 11v, multiply, plus into minus is minus, 11 8 is 88 and 2 176 uv, 100% correct. Then plus 2 11v 2w, that means BC, that will be 2 into 1122 to the 44, therefore it is correct, it is there, 44 VW. And the third one is plus 2 CA, that will be plus 2 into 2W minus 8U, plus into minus is minus 8 to the 16 and 16 to the 32W, that is also there. So if we have got all the terms of the expansion of A plus B plus C whole to square, therefore the first that is A is minus 8U here, B is 11V and C is 2W. Therefore I can write it as A plus B plus C whole to square. Therefore it is minus 8U plus 11V plus 2W whole to square. So therefore the factors are minus 8U plus 11V plus 2W minus 8U plus 11W plus 11V plus 2W. So they are the 2 factors there. Now remember that. Now let us begin to learn the solutions of examples of exercise set 4.5 of Ganita Manjari 9th standard NCERT textbook. Now here the first example given is to simplify rational expressions. So please go through the rational expressions video which is available on this channel. You should know what are rational expressions, what are the properties of rational expressions and the operations on rational expressions. Now here let us understand what is the question asked and let us also understand how to solve them. Now the first example here is 3p square minus 3pq minus 18q square divided by p square plus 3pq minus 10q square is a rational expression. Now we have been asked to simplify it. Now to simplify that we have to find out the factors of the numerator and the factors of the denominator, the factors of the polynomial in the numerator and the factors of the polynomial in the denominator. Now let us take 3 common in this. So 3 is taken as common. So what remains is p square minus pq minus 6q square. So now p square minus pq minus 6q square I have taken it separately. Now by middle term splitting method I can split it as minus 3pq plus 2pq, that is minus pq, minus into plus is minus 3 into 2 is 6, therefore it is the correct splitting. Therefore I can split as p square minus 3pq plus 2pq minus 6q square. Grouping that I group it as p square minus 3pq and 2pq minus 6q square. So taking p common here it is p minus 3q, taking 2q common here it is p minus 3q. Therefore the factors are p minus 3q and p plus 2q, and that is the numerator I have got. Now coming to the denominator is p square plus 3pq minus 10q square. Again carry out the factorization by middle term splitting method. Now when I add I should get plus 3. So plus 5 minus 2 is plus 3. Plus into minus is minus. 5 into 2 is 10, and therefore it is the correct splitting. So common thing in this is p is common. Taking p outside I get p plus 5q, and here 2q is common, so taking 2 minus 2q outside I get p plus 5q. Again p plus 5q is common, so I get p plus 5q and p minus 2q. They are the factors of the given polynomial here. Then writing them in the denominator, so therefore I have got here 3 in the bracket p minus 3q, p plus 2q divided by p plus 5q, p minus 2q. Nothing is there common in this, nothing gets cancelled here. So that is the simplification of the given rational expression. So try to understand that. Now coming to the next example. Now we are given a rational expression n cube minus 3n square m plus 3nm square minus m cube divided by 5m square minus 10mn plus 5n square. Now to simplify that, I have taken the numerator separately, so I have to carry out the factorization of that. Now if you look at the polynomial here, I got the first term as n cube, the last term as m cube with a minus sign, therefore possibly it is a cube minus b cube form, therefore it is correct. A cube minus 3a square b plus 3ab square minus b cube is identity, so I can apply this identity and write a as n and b as m, therefore it is an expansion of n minus m whole to cube using the identity that a cube minus b, a minus b whole to cube is a cube minus 3a square b plus 3ab square and minus b cube. So the numerator became n minus m whole to 3 there. Now come to the denominator. The denominator is 5m square minus 10mn plus 5n square. Now I can go for Middleton splitting method. So minus 5 minus 10 it is, minus into minus is plus, 5 into 5 is 25m square in square, so therefore splitting is correct. Now grouping it, now I can take 5m as common here. 5m if I take common, it is m minus n, 5n is common here, m minus n. Now I have m minus n common here, m minus I have taken here outside, and in the bracket I get 5m minus 5n. And 5 is also common, so take 5 outside, so it will be m minus n into m minus n. Now if you observe here, I have taken minus sign outside. I'll tell you why I have taken it outside. So when I take minus sign outside, I can interchange the position of n and m, so it became n minus m here. Again I have taken minus sign here outside, I have interchanged the positions of n and m, therefore it is n minus m. Minus into minus becomes plus, 5 into n minus m into n minus m. So the denominator becomes 5 into n minus m into n minus m, and the numerator is n minus m whole to cube, therefore it becomes n minus m into n minus m into n minus m, and you see n minus m gets cancelled there, and what remains is n minus m by 5. So I change the sign here because I saw the numerator as n minus m cube, here it is m minus n, so by taking the signs outside, I converted n minus n, that is m minus n into n minus m, so that I could cancel the terms in the numerator and the denominator, and therefore the answer I got is n minus m by 5. So try to remember that. Now the next example is w cube minus v cube plus x cube plus 3w vx, and the denominator is w square plus v square plus x square minus 2wv minus 2vx plus 2wx. Now looking at the polynomial here, I have 3 cube terms, that means it resembles an identity a cube plus b cube plus c cube minus 3abc, so that I can use the identity there. So now let me write it in a standard form: w cube plus minus v cube plus x cube, that means it is a cube plus b cube plus c cube. Now minus 3a, w is 3 a here, w is a, and minus is v is b and x. So multiply, minus into minus is plus, and 100% correct it is. Therefore it is of the form a cube plus b cube plus c cube minus 3abc. So I can use the identity a plus b plus c in the bracket a square plus b square plus c square minus ab minus bc minus ca. I can write the numerator accordingly, and that's what I have written here. W, that means it becomes a plus b plus c becomes w minus v plus x, and a square is w square, b square is v square, and c square is x square, and minus ab, that it will be minus w in the bracket minus v, and minus of minus vx minus of xw, and take the denominator now, and the denominator I have 3 square terms there, and it's very clearly visible. It is of the form a plus b plus c whole to square. So let us see whether it is possible like that. So if I take a square here, a square is there, b square is there, c square is there, 2ab is there, 2bc is there, 2ca is there. Therefore I can use the identity a plus b plus c whole to square. So I can replace this by a plus b plus c whole to square. Here a is w, b is minus v, and c is x. Therefore it will be w minus v plus x whole to square. So that is the denominator. So in the numerator we have w minus v plus x, and in the numerator we have got w minus v plus x, and the denominator we have got w minus v plus x whole to square. So I can cancel it. So the square term cancels there, and what remains behind is w square plus v square plus x square, minus into minus is plus wv, minus into minus plus is plus vx, and minus xw divided by w minus v plus x, and that is what is the simplification of the given rational expression. So let us go further. Now here in this example number 4, I have been given 4y square minus 20yz plus 25z square divided by 25z square minus 4y square. Now if you look at the term here, it is a square term, and this is also a square term. So I can apply the identity here. If I apply the identity a square minus 2ab plus b square, a square is clear, it is 2y whole to square, and 2ab is 2 into 2y 5z, because 5z square is there, so it is 2y minus 5z whole to square. Therefore I can replace the numerator by 2y minus 5z whole to square. And if you look at this, it is 5z square and minus that is 2y whole to square. That means I can write this as 5z whole to square minus 2y whole to square. It is a square minus b square form, so I can write it as 5z plus 2y, 5z minus 2y. And if you observe very carefully, I have 5z minus 2y here, whereas I have 2y minus 5z. I can take minus sign outside, so I can write it as 5z minus 2y. So 5z minus 2y and 5z minus 2y gets cancelled, and what remains is minus times 2y minus 5z divided by 5z plus 2y. Now I can take this minus sign inside again, so it will become 5z minus 2y. So the answer is 5z minus 2y divided by 5z plus 2y, and further it does not get cancelled, and that is the simplification of the given rational expression. Try to understand why I have taken the minus sign outside here and why I have taken minus sign inside, how I have taken minus sign inside here. So try to understand that. Now coming to the example number 5, x square plus x minus 6, x square minus 7x plus 12 divided by x square minus 6x plus 8 and x square minus 9. So there are different trinomials and binomial here. So let us go for factorization of each of them. So let us take x square plus x minus 6 here by Middleton splitting method. It is x square plus 3x minus 2x minus 6, because plus 3x minus 2x is plus x, and plus 3 into minus 2 is minus 6, therefore it is the correct splitting. So take the common thing, x is common here, x plus 3, minus 2 is common here, minus 2 in the bracket x plus 3, and therefore x plus 3 is common here, so x plus 3x minus 2. That is the factorization of the first algebraic, the first polynomial of the numerator. Take the second one, x square minus 7x plus 12, x square minus, I can split it, x square minus 4x minus 3x plus 12, because minus 4 minus 3 becomes minus 7, minus into minus is plus, 4 into 3 is 12, and the correct splitting it is. Therefore x is common here, taking x outside, x minus 4, minus 3 in the bracket x minus 4, and x minus 4 is common, so take is outside, and x minus 3, therefore they are the two factors of the second polynomial in the numerator. Now let us go to the third one, x square minus 6x plus 8 now. Now taking x square plus 6x plus 8, again go by Middleton splitting method. Again minus 4 minus 2 is minus 6, minus into minus is plus, 4 to the 8, it is correct. So x is common, take x outside, x minus 4, and here 2 is out, 2 is common, take 2 outside, minus 2 in the bracket x minus 4. The factors are x minus 4 and x minus 2, that I have got it. Now coming to x square minus 9, it is x square minus 3 square, therefore x square minus b square form, it is x plus 3 into x minus 3. So we have got all the factors of the polynomials of the numerator and the denominators. Substitute them. We have got x square plus x minus 6 as x plus 3 into x minus 2, x square minus 7x plus 12 as x minus 4 x minus 3, x square minus 6 plus 8 as x minus 4 into x minus 2, and x square minus 9 as x plus 3 into x minus 3. So now cancel all of them which you can cancel. X plus 3 gets cancelled, x minus 3 gets cancelled, x minus 4 gets cancelled, x minus 2 and x minus 2 gets cancelled. So therefore the answer is 1. So that is what is the simplification of the given rational expression. Now coming to the next example, that is p raised to 4 minus 16 divided by p square minus 4p plus 4. Now p raised to 4 minus 16 can be written as p square square minus 4 square, and p square minus 4p plus 4, if I factorize it, I get p square minus 2p into 2 plus 2 square. That means it is p minus 2 whole to square. So I have written here p minus 2 whole to square. So p square square minus 4 square can be written as p square minus 4 into p square plus 4, that is a square minus b square form, and p minus 2 square I can write it as it is. And now p square minus 4 will be p square minus 2 square and divided by into p square plus 4. P square minus 2 square, again applying a square minus b square form, I get p minus 2 into p plus 2 into p square plus 4 divided by p minus 2 whole to square. So p minus 2 gets cancelled with power 2 here. So what remains behind is p plus 2 in the bracket p square plus 4 divided by p minus 2. So that is the simplification of the given rational expressions. So that is how we have solved. The solutions of the examples are completed. So learn the basics of that is identities, how to apply the identities, remember the identities, apply them, and also remember as to what are rational expressions and how to simplify rational expressions. For rational expressions I'll be putting a separate video where you can learn the basics of rational expressions. Okay, learn them, understand, and note down them in a book so that you can refer them whenever you want. Okay, thank you.